Thank you, Lulu. Hi, hi everyone. I'm Tharindu, and we have Supun and Daniel also with us. And we are here today to talk about making games for the web. So I hope you have played at least once games on your computer or phone using a web browser. So well, those are called web games. In this FICA, we are going to learn about how these games are created. We'll talk about the things like programming languages used, how the pictures and animations are made, and even how the sounds and music are added. So whether you wanted to become a web game developer or just wanted to know how the games are made, this FICA will be useful. So let's get started. So a sneak peek, just before we begin, here are some demos that we are going to build today, like after this introduction. So yeah, before that, we have to like complete three missions. Like first one is introduction to web game development. After we finish that, we can move on to phase three and React Free Fiber demos. So let's move into the introduction part. So, web game development has become really popular these days. I think you have noticed how easy to play games online using just your web browser. So it's super convenient because you don't have to download anything or buy a special gaming device. You can simply open up your browser and on your computer or a phone or a tablet, you can start playing games right away. So this accessibility has made the web games a big hit. So especially with mobile devices being so common. So now you can enjoy games wherever you are, whenever you want. And the best part is more and more people are getting into this web game development because the tools and technologies that needed for the creator these games have become so accessible. So it's an exciting time for the web game developers. So it's no wonder industry is growing so fast. So let's so yeah. To become a web game developer, it's all about you need to know a few things like programming, HTML, CSS, web technologies, such as those things. So uh, if we get JavaScript is the main language, it makes things happen and adds the interactivity to the games. So we can use HTML and CSS to structure the web pages and make them look nice. Like HTML is like the skeleton, and CSS adds the colors and styles. So then we can use web technologies like web audio, WebRTC, with WebRTC, we can connect players and let them interact with real time. And also we need math we use math to figure out positions, movements, and collisions, and also create realistic physics in the games. So with all of these things, we can create a awesome web game. So let's move on to the next slide. So it's about we are going to talk about key components of web game development. So the first one is programming languages. So when it comes to web game development, we have a handful of programming languages that brings our games to life. So here JavaScript is the superstar. Like it runs directly on the web browsers and makes our games interactive and fun. And TypeScript is like JavaScript's smart cousin. And we have Python. It's another cool language. It's known for its simplicity and readability, so making it like a favorite among the beginners. And also talk about like C Sharp with Unity. It's a powerful combination for creating amazing 2D and 3D games. Like C Sharp controls the game's behavior, and the Unity brings the vision to life. So we have like plenty of options to create web games. It's all about finding the right language for our goals. So yeah, let's move into the next key component. It's graphics and rendering. So graphics and rendering are like essential part in the web game development. So like we can create like visual appealing experience for the players. So like we are using like for 2D games, we can use the Canvas API, like which allows us to draw and manipulate graphics elements like the sprites, backgrounds, and uh, other UI elements. And we have like other like JavaScript libraries called Fixie.js, Create.js, and they will provide like additional features, and it'll easier to create 2D game development. And when it comes to 3D games, we have WebGL. It's the technology of choice, and to simplify the process, we have 3JS. So it's a popular JavaScript library that makes rendering animations and interaction more accessible. So in summary, we can use Canvas API for the 2D games and WebGL for the 3D games. And let's talk about like audio and sounds. So audio and sounds elements, like we can use Web API. So like popular technology used for like creating and manipulating audio in the web games, even in web-based solutions. And to get like multiplayer and networking capabilities, we can use technologies such as WebSockets and then WebRTC for real-time communication between the players. So let's move into the key component number five. It's collision detection. Let's say like if you think about like what is collision detections, like in your game, it's important to have like interaction between different characters or objects. So this is where like collision detections comes into play. So it plays like it helps to determine like if two objects or sprites are colliding with each other based on their positions, like especially they are like x and y coordinates. So to implement collision detection, you will need a function that compares the coordinates of two game objects or sprites. Like this function will run in a loop throughout the gameplay and continuously checking for the collisions. So inside this loop, you have the flexibility to define what happens when a collision occurs. Like for example, one object can collide with each other. It's causing to bump or like some kind of a effect, and alternatively, like an object can be destroyed upon a collision. So it's like it's up to you. With your game requirements, you can decide what happens after collision. Yeah, that's about collision detection. And then we have physics engine. So in JavaScript development or any other game development, like the physics engine takes care of the complex calculation for the motion and collisions. So it continuously updates the object's positions, velocity, and acceleration using formulas like Newton laws, and it uses the real life physics to implement those things. So this engine simplifies the coding by automating like this calculation and sending the data to GPU. So developers can focus on that, creating the gameplay like without dealing with those complicated math. So we have MetaJS as a library we can use with Phase 3 and JavaScript game development. And we have another cool part, which is game AI. For develop this game AI, we have a library called Yuka. So Yuka is a nice tool for web game development, which like brings a bunch of cool features to make your games like game entities more smarter and more interactive. So one of its handy features like steering. So it let you to built-in use built-in vehicle models and behaviors to make your game entities move around like realistic and dynamically. And navigation is another cool feature. It provides like graph classes, search algorithms, and navigation mesh implementation. So it allows your game entities to find efficient paths, and even when faced with obstacles. And then we have perception. It gives your game entities short-term memory and vision by making them aware of surrounding and enabling them to make decisions based on what they see. And next thing is triggers. Like you can set up triggers that activate specific events or behaviors when certain conditions are met. So it's up to you to decide what are the triggers that you're going to meet for your game. And last but not least, there's physiologic. So this intelligence system in Yuka allows you to like your game's entities to make more human-like decisions and react intelligently to the different situations. So I show some examples here. In this first thing, the in this example, a game entity has a goal to collect items, and it will rest for a few seconds, and it will again find other items around it. And then in this example, we use fuzzy logic. It will detect like if the enemy is closer, it will move to a shotgun, and if the enemy is far away, it will automatically shoot to a sniper or something like that. So those things are like based on this game AI. And yes, now we have game engines. So before we jump into the like specific game engine, let's get idea about what is a game engine like that. Like think of like a game engine is like a backbone of a game. Like it's like a special software framework that gives developers a head start in creating their games. So it provides all sort of handy tools like resources, functionalities to make their life easier. So a game engine take care of about the all the technical stuff behind the scenes. So we talk about uh, like collision detection, physics, and all of those things. It will take care by these game engines. So basically, like with that, developers can focus on their creative side. So and now we can like get some idea about Phase 3 framework and React 3 Fiber library. We'll talk about some pros and cons. In Phase 3, we use Phase 3 to develop 2D games in SNT. So when you talk about pros, it's really easy to learn, and it has types support, and also it has its own physics engine, and also we can like identify like collisions as well, and it has like large community, and it has plugin support as well, and it support both WebGL and Canvas support. But we found that they even though they had some state management that was not sufficient for us. So because of that, for state management thing, we had to use Mobex instead of their own thing, and also their responsiveness is not that great. So because of that, we have to create our own scale manager to work with desktops and mobiles as well. So that's our thoughts on phase 3. And then we have reactory fiber. It's also easy to learn, and it has plenty of examples and good documentation, and it has a large community. So we mainly use reactory fiber to use more 3D games, not 2D games. So it's a powerful tool to add 3D elements to the websites, and it can handle screen responsiveness as well, and most importantly, it familiar with React hooks. So that's about the React 3 fiber. So I think the introduction part is done. So it's over to you, Daniel.
Thank you, Tharindu. So let's take a look at phase 3. So here we have the phase 3 main documentation. So currently their website is having a small they're having a rebuild of their own website. So a lot of their documentation and everything are being updated. So here we see that you have Phaser that is downloadable from GitHub, and also a lot of examples for many of their classes and functions that are available within Phaser. So if we go into that application, you can see uh, the amount of things that is doable through Phaser, and there's a lot of functions that and similar things that you can do with Phaser. So here as well in the API documentations, you have all classes, events, game objects, physics, and everything explained in detail. So please give that a read so you can get a basic idea on how Phaser works. And also, this is the Phase HTML framework, like the main page where you can also learn how to configure your own Phaser game. So Phaser is used very widely within the web game community, and some top games that are made with Phaser, you can go and check it out. Uh, Basically, on this website, it's called itch.io, and within it, you find a lot of very interesting games and very retro but arcade games as well. So let's move on to our little demo of Phaser. So this is a small game that I made using Phaser. As you can see, it's something like two cars, but there's no two cars. There's just one play object. So as you can see, you can do cool stuff like this with it. So let's dive into the code a little bit. So here we have a main game folder, which is like a config folder on where how we tell the instance of the game of what we need. Basically, we set our background color with the scenes and also the physics here. So Phaser has two main types of physics. One is arcade physics, and the other is a physics library called matter.js, which is combined with Phaser to make a lot of realistic physics rather than the arcade type of physics. So Phaser is basically meant for game development with this. So here we have our main Phaser file where we'll be creating all our um, main components for the game. As you can see, we create the background, the scoreboard, the players, and the obstacles, and all of that. But before doing all of that, we have to load our assets um, because Phaser is basically using WebGL, so we had to preload all of our images in order for them to basically be used within Phaser. It has Phaser has a lot of life cycles. So one of the three life cycles I normally use preload, create, and update. Basically, preload will happen before the game is being created, and create will happen when the game is being created, and upload will happen 60 times during the game, like while the game is running. Basically, it'll run 60 times while the game is running for every second. So here we can see that like the player and the physics and all have been added here. So if we dive into our game a little bit, you see that our player is actually colliding with the object far more earlier than what we need to see. So let's just dive into like the game folder and see that we have our debug turned to true. And with this, we can see that all of our collision boxes. So you see we have a huge square here, and that's not what we basically would like to have, because that's not the bounds of our image. So don't worry, Phase has a way to solve this as well. So as you can see, the normal bound box is a square in Phaser. So we can actually set it to a circle as well. So if we go here now, you can see that our game object is having a circular physics collider box. Like that, Phaser is very flexible when it comes to its physics engines. Also, something that you might want to look into is physics editor, which helps you draw your collision shapes for very complex objects rather than circles or squares. Um, which is actually very compatible with Phaser that we also use during a lot of our projects because we had a lot of complex objects to work with. Phaser runs on scenes. So here we have our main scene, and here we have a game over pop-up scene. So when one scene is, so due to like the collisions, when one scene ends, another scene will begin. And using these scenes, we can do a lot of things, as we can go from transitions, cut scenes, and do all of that. So also, as you can see, when my play is moving, we have like a small moving animation. Normally, if you don't add these animations separately, you will not get them. It's like just basic movement. So for that, phase has something called tweens. So tweens basically helps you do those animations. Basically, it will target. Currently, it's targeting my play object, and it will change the y value according to what I pass in through here. And here I can give like the duration of how long it will take for this object to go from this y value to this y value. So here we are running at 400 milliseconds. So if I say 600 milliseconds, you'd see back in the game that I'd have like a slower, yeah, I'd have like a slower movement. But for my game currently, we do not need such a slow movement, because or it will be unplayable for people. So we have it set to 400 milliseconds. So it's easier for us to navigate through it. So like this, what I want to say is that Phase is very flexible, and it's very easy to learn, because if you go through the documentation, it's very straightforward. And if you read through all of the examples that they provide, it's very helpful, and they have categorized it very well as well. And also, even if, like when you go through the examples that Phase has provided, yeah, sorry. Um, Here when you can also like edit the code that has been given, or else go to its source code, which will redirect you to the Phaser GitHub. And you can basically look through these source codes and figure out what you want. So Phaser is such a flexible and interesting framework. So I think you all should also give a try for this as well. So now I will pass it over to Supun, so that he can give you a demo on React Tree Fiber.
Hi, hi. Good evening. I'm Supun Sethsara. So what I'm going to show is like now you have some idea about how to use 2D, how to use some framework to like build a 2D games. Now let's see what you can do with the 3D. So first of all, I will go through what I'm going to show you in this demo. So mainly what I'm going to do is like building this kind of website. So it's kind of like you can rotate around this 3D object, and also you can click here to make it the propeller speed faster, make the propeller speed faster and slower, and also change the color of this plane. So this is the demo. I'm going to show you how to build this one. First of all, let's see what are the tools you need to know for this one. First of all, what we are using is 3JS. 3JS is uh, Stages is a framework, sorry, a 3D library that you can use to add 3D elements to the website. And there are a lot of plenty of documentation. If you go to 3js.org, you can find a lot of documentations and also examples. I'm not going to tell you much about the 3js. If you just visit this, I just invite you to visit this web page and go through these examples, and you definitely going to excited about this 3js. So for this demo, we are not going to show you how to doing this with the 3JS. What we are using is a React Tree Fiber. React Tree Fiber is a 3JS, sorry, React renderer for 3JS. It's kind of like if you have a previous experience in React, just like you building a normal React application, React web application, you can create some 3D environment on top of the website. So that's the cool thing about this React.js. So I will show you how to do that. Let's if you go to the installation, you can find a lot of uh, uh, you can find the step-by-step guide to like how to start a React project. So first of all, you have to create the React project. So and also just make it start. So I already created the React project, and if I go to my React, it's like default React page is here. So I already started this one. And then what you have to do is like you have to add some packages. So in package wise, this is a core package you can use with a React Tree Fiber. It's really helpful for you. There are a lot of functionality that will useful for you to like without doing by yourself. You can already build functionalities are here. As example, cameras, controls, and everything here. You can use it easily. So you need this one, this package, just like if you go to github.com, there GitHub page, you can find the instruction how to install this one, or you can just go to React Tree Fiber documentation and click this black button and click this tray, and you will navigate to this page. So after you install this one, you can just install just like you would in the node packages. So then other thing you need is this Leva. Leva is some kind of like you can create a UV panels on top of this Tree.js application. It's really easy to use. You can just go to this Leva GitHub page and just find a lot of instructions. So I'm going to install that one also. So then for the adding 3D object, you need to 3D object definitely. So what you can do is like you can create by your own self using Blender 3D or Maya 3D application, or you just go to Blend like page. It's a lot of blend 3D models for Blender. So I choose this one. It's already there from some other creator done this 3D model. So I'm going to use this one, and if after I import it to the Blender, I just open it on Blender, it look like this. So it is kind of say, just you can see it's everything's perfectly there. So I just make a few changes. You have to just I just make all this object as a one, and also profile as a different object. So because of that, I know I need to like action to like rotate this profile. And other thing you need to care about, just I'm not going to explain much about how to just export to from Blender to React.js, but what like there are a lot of plenty of examples on YouTube just how to do that. But anyway, things you need to be careful when you are exporting. Just make sure that this object name is correctly assigned, some meaningful one, and also profile. So other one also you have to do this, but I'm not going to do all thing. But anyway, after that you can export that into JLTF format. So you can export it to GLT formats, but I already done that. Because of that, I'm not going to do that. Anyway, then if I go to project, so this is the project that default React startup application. So you can see the React tray package, fiber, and also Leva I already installed here. So let's add some code here and see how it's happening. First of all, I'm going to change this one. I'm going to remove all this from here, and I just already prepared this one. Because of that, I will go through its code line by line because it will helpful for you. So so here I just pre-prepared this code. What happening is like if I just save it and go back to the web page, you can see its color, different color is here, and also this is a Leva panel. You can just add the color here, so you can change the color. So but what you can see is this not fill out whole web page. You can just go to application, and I already prepare CSS. I'm not going to explain all thing about CSS how to do that, but it's kind of like just replace the default CSS file with this code. It's kind of like just add that container width and height to like match it to the screen size, and also add some colors. It's only enough for this one. So after that, you will see it's something like this. It's working fine. So I will explain the code what I did on AppJS. It's kind of like you import these Leva packages. So you need the use controller and orbit controller and or stage. It's already there. So what happened is the use controller is you can add the color here and also any property, any number of properties here, and also what property do. So here color assigned with the color coordinate. But think about I need to change a plain color also. Just add this one. I already had that. But if it is not there, you can edit again and make it just same one. So if I save this one, you can see plain color is already there. It's not doing anything, but it is there. So and also you can just go here and just make it number. Uh, then if I go back to here, you can see it is number now. So it's kind of like that. It's really easy to use this Leva package. You can just add the configurations for your 3D web page or just do customized here. Anything you can do it here. So that's it about Leva. And then what we are doing is we use a canvas here. On inside the canvas, we just add these elements. So it is like a default if you 3JS application, you have to add the canvas here. So and also stage is something we get from Dre. It is something like we create a whole environment without doing one by one. We don't have to skyboxes or any lighting, everything, lighting and the kind of things. It's everything handled with this stage. So it's kind of easy for you. So add that, and there are a lot of properties. It's kind of change the settings. If you go over it, you can see different kind of environment maps are there. You can use those, and also shadows and those kinds of things. You can do that. And then orbit control is the camera, how it's rotating. So I have to add the 3D object to show you how it's happening. Let's first add a 3D object. So for that, so lighthouse object already there. So what you have to do is yes. So what you have to do is just import lighthouse object. So just go here and you can see lighthouse object is here. So you have to drag and drop it to GLB file inside the public folder. Anyway, I name it a model folder and just put inside this model folder. So everything is prepared. The model is ready. So then what we have to do is just import it to the make it as a React page. Sorry, React code. So here there's a code I already prepared, nf npx gltf jsx. This is the command that you have to use. Then you have to just give that folder path. So it's a public folder, models and lighthouse. So then what you are just press enter. Sorry. It will take some time. Oh no, it's make fast. So what is happened is like it's create this lighthouse.jx file. It is kind of like if you go to it, it's like a React page. So sorry, React code. So everything React function, everything like just like a React function, everything prepared for you. So all these things are like small 3D elements of your 3D model stack. And so go here. These all few small things divided into these small mesh elements. So what you have to do is just make it prepare for your code. Just create a component. Components folder, then add it to inside the components folder. So I'm going to move it here. This is like a just like you when you're if you're familiar with the React, it's kind of like a React component. So then what I'm going to do is rename this modules to Lighthouse, and other thing you have to do is change this to model models / Lighthouse. Yes, this is what you have to do, and then copy this one. This is where I import this not done materials to the function, and there are another place. Here what happens is preload this 3D object to the function React application. So you have to name those areas, those places, and now everything is ready. Then what you have to do is just go to just chase your main code area, and then just under the stage and in brackets. So what you have to do is just import lighthouse. Yes. So that's it. That's all you have to do. If I go back to page, yes, this is the 3D model that it's really easy to do. If you were to add the creator product page, like some page, like shopping page with the 3D elements, that's all you have to do. So it's really easy to do that with the React 3.5. So now I'll show you some cool stuff with this. Just separate this plain object from the whole scene and just animate it. For that, what I'm going to do is just go to here. So I have to find where this C plane is. So, yeah. So as I mentioned, like I already named it as a C plane. It is there. So there are three plane object. Don't worry about, because there are like three materials assigned to this object. That's why it's happening. And also the propeller is also there. So I have to take both of them away from this object. So I just create a new one, plane dot JSX. Okay. So since there's limited time, I'm not going to code everything, but I have prepared this one. So you can just close this. Okay. So it's kind of like this. Without this one, you can create. You have to add node and everything. What I'm going to do is just copy this part. Copy this part here. And also you have to add the props. You have to not and materials. Like if you have no any previous experience in React, you may be some confused with this, but don't worry. Just it's really easy to learn React with the React hooks. And if you get familiar with React, I just suggest you that before you doing something like this, just start with the React and learn about the React hooks. So it's better for you. But anyway, so when it come to not you have to add the props here. So it's kind of like passing from lighthouse to plane object. So the parameters that's passing from data that's passing from lighthouse to plane. So let's see how to import it. Now if I save this one, I go back to here, and it's still there. Yeah, you can see plane was missing. It disappeared, maybe fly away. Okay, then yeah, so then lighthouse object, I'm going to add this plane again. So you have to do is just like normal React, you can add that plane to here. But anyway, you have to add these props first. So maybe nodes. I have to add nodes. And also materials. Okay. So now everything okay. I think it should work. Yeah, it is there. The plane is now there. So it came back. So the plane is here. Now what I'm going to show you a small demonstration of something cool with this. So I promise you to do something cool. So let's do something cool. Then what we have to do is just make a propeller. Just rotate this propeller. It's just I also just what you have to do is just give a second. Yeah. So create a constant with a propeller speed. You can array as because you can change it later. And also we using this small code. I will explain it a little bit. And also, yeah, that's all you have to do. What will happen is, if you are familiar with React so React hooks, you get to understand most of them. But anyway, what is happening, I will explain. This use reference is like for like get reference for the HTML objects, like elements in the React application. And also the use frame is a custom. It is a custom. It's not like React functionality. It's like a custom hook that built for Fiber. It is something like if you have familiar with Unity or Unreal game engine, you know that there's a function called update. What it's doing is like it's update it every frame per second it's update. That's how normal game, right? Every frame per second, like 30 or 60 frame per second, this functionality get executed. So this is the same thing. It is similar to the update function. So for here, I just renamed it, and because of that, I renamed here. And what happened is it's just a calculation. It's doing a calculation to like the speed the propeller rotate in C-axis. So I am going to add this to, I think, add it to the propeller. So it is a propeller thing, propeller group. So I'm just give reference to propeller reference. So now if I save this one, I go back, you can see propeller is rotating. So this is something we have done, and also some other thing, something cool, very easy thing with the React 3 5, not React 5 with Dray. Dray, you can do with the Dray. So like I can add this float function. Sorry, it is not important. Float. Okay, so it is a float thing. What is doing? It's to make this objects like floating. Like if it is a sky, if the plane is on sky, or if in the ground, like here it's a sea. So I want to make it like a floating on top of the sea. So let's see what happens. So I just add the floating. So you have to just functionality. I will prepare. Just you have to play around. If you want to know more about these things, you can go to Dray documentation, and just here all things are well explained here. So just I did that, and if I go back to my code, uh, yeah, you can see there's a small like wave with a sea. It's like a plane is waving. It's not moving up and down. So now it is also done. So next step, what I am going to do is I just make some functions. So when it comes to games, there should be games or some interaction 3D object website. You have to like click functionality, click a button, everything. So let's see how can do something like that. So for that, what we're going to do, what I'm going to do is just on the group, I just use this on click, and also this is a use state. It's kind of like variable state actually. And when it comes to React, it is also on React hook functionality. So what it's doing is like it's saving, and also you can set this value with this function, and also it assigned to the here. So what happened here, like I just check that profile speed is less lower than 50, and if it is 50 I make it 50, and if it is not I make it 10. So that's the thing happen, and we don't need this one anymore, this constant. We just add this one here. And you can see now if I go to my application, if I click this plane, it's like rotating fast, and if I click this, it's rotating slow. I'm sorry, maybe like because of this streaming there you can maybe notice, but anyway at the end of I will share some hosted version of this one. We can try it on a mobile how it's cool is. And also let's do another thing. You can just we created that at the beginning we create plain color. So just like we do in the React, we pass it as a parameter inside the lighthouse and also plain. Okay, it is here, and go inside the lighthouse, and you just pass it to the plain. I think you have props, the plain color, and also it is done. And here you can edit here. Was it? And I just want to like create a new material. So for that, this plain body, I need to change this plain body. I want to change the color of this plane. So what I'm going to do is just make it like not a short version with the end bracket. I just make it like this. And also I using mesh. They are like inbuilt mesh as shaders in a 3JS. So I'm using mesh standard materials. So yes, it is done. you can keep it anyway, just like this. So, and then I make it color equal plain color. And also I think we don't need this material anymore because it is already there. Let's see, I save it. I saved it, and let's see, I'll refresh it. And yeah, it's working. So if I go to, like, now it's a yellow color, if I go to plain color here and change it, you can see it is changing. So something you can do is, if you are using a customized product, customized configurable page, so you can do something like that for that website. So that's all about the 3JS presentation. And one more thing I think I have missed. Think okay, yeah, everything is fine. Yeah, so that's all about the React. And other things you can do. So this is like not a game, but there's a click functionality here. You can just move with something. So I have some other example that we just as a POC projects. So here you can see this one. This is like a same kind of functionality, but it is floating on the sky. And if I scroll here, if I scroll through the website, this plane is moving toward this line. So you can put some information on top of there. So this like work as a totally uh, cool website. So this is something we have done as a POC, and also here we have tried to build another POC with the character. Like you can move around with this character, and also some actions you can edit. So yeah, so we can do a lot of cool stuff with React. Sorry, 3JS, but with the React 3JS, React 3 fiber, you can like utilize that coolness in the React application to build in this one, and also you can manage your code well. So yeah, that's all about this 3JS, and I'm handing over to the Lulu to for the Q&A session.
Thank you so much to Supun, Tharindu, and Daniel. Does anyone have any questions? You just pop them in the chat. Okay, I think we have a question. In your experience, yeah, sorry, is there anyone in particular you're asking this question from? Can you look in the chat? Daniel and Supun. In your experience, what was the most time-consuming component or aspect when working with Phaser and with React 3 Fiber?
So for me, it would most definitely be the scale manager when we were working with Phaser. I think we spent a lot of time figuring out something that did work well with both desktop and the mobile versions. But from things that we demonstrated today, I'd say the physics engines and all.
Uh, for me, React.js, 3JS, it's kind of like same. So V6 engine and everything handling is really something hard. But anyway, there are different packages like already built. Like you can use Canon.js, or there are many more that just like Tharindu explained in the presentation, they are like already built. Physics engines are there for JavaScript. You can use them. And also when it comes to like optimization, like large environment. We can build those large environment with the React tree. If you go to Tree.js website and go to example, you can see a lot of example with large environments that built on top of Tree.js. But when it comes to do that, you have to like careful about how to optimize this one, and also performance wise you have to careful that area. So this will be very time consuming.
Does anyone have any more questions?
Lovely. Thank you everyone for attending today's session. A recording will be available on our YouTube channel in a couple of days, so just keep an eye out. And please follow us on social media, so Instagram, Facebook, LinkedIn, and YouTube, to stay updated about our next Fika session. Have a continued good day and see you at the next one. Good night.